Okay. I'm not sure of your question. Can you hold on one second? Do you want to say it? Can you unmute yourself? That may be easier. Or tell me if it's a question from your homework. See, I'm gonna unmute you. Let me see if I have to do it. Okay, I can hear you. If you want to just tell me what you're asking.
Okay, yeah, because we had similar questions like this in the iMathis homework, and where they were asking to solve it as where A would equal to and B would equal to as a functions, and I had difficulties trying to insert the answers. Like I got the answers that you got, but in iMathis, it makes it difficult to input the answers.
Which homework? I'm gonna go to your specific homework.
Sure. For an example, let me go. I think it was the last
Do you know
6.3.
do you know your CRN? I've got three of you. Do you know? You probably don't know that. I'll find you. Let me see. Uh, Martin. Okay. Oh, I found you. Okay. So it is chapter 6, right?
6.3. And if you look at the first question,
Okay, perfect. All they want is to put, so if you're saying it was x plus 7 squared plus or minus 44, then they just want you to put A is the 7 and B is minus 44.
yeah, I
So
did
all
that. And for some weird reason, iMathis was still inputting my answer wrong. I even tried doing the x plus 7 squared,
no,
and
all
it's
you have to put is 7. All you have to put is 7. All you put is 7. You
yeah,
put
I tried
7
that, and it was still marking it wrong.
because I'm trying to see. I see where you input stuff, but yeah, if you put,
Yeah, I
yeah,
tried
I'll give
like
you credit
every
for it
answer,
'cause I
like
see
trying to
it.
put
I
it
see
in
you
every
got
way
X.
possible, and it was just chaos.
Yeah, well, I see you put X plus 7, so I'm going to give you full credit right now. But it's what it's asking for, and I don't know if it was just being funny, but A, it just wants you to put whatever you got to go in that A spot, and that would be 7, which is what you have. And then it gave you credit for the negative 44, but it was confused about the X plus 7. So,
Yeah, because the
but I gave you
question
full credit for that one.
Yeah, because
And
questions one, two, three, there were one, two, I think five, because the other ones didn't let us answer. It was all like that, and I even tried putting the 7 by itself, and it for some weird reason it wouldn't take it. So I was trying
that's
to
weird.
input it every way possible, and I don't know.
Right. 'Cause it looks like, yeah, it's fine. Yeah. Well, I've given you credit for that. And then for number 2, I see you have an I. So there's no I, but it is a 1. So I think you tried to put, like, I'm looking at your number 2. Like, you put, okay, okay, well, it's not negative 1. It's positive 1, which you even, yeah, I think what happened is that, like for your number 2, you eventually got that A is 1 and B is 103. But based on your attempts, because I can see every single attempt, like you put negative 1 for A, but the answer was 1. But then you put 103 for B, so then you got half credit. And then another time you put like 1, you put X plus 1, but iMath wanted 1, and then you put 103, because you know what I'm saying? So
Yeah, I tried messing around with it, and for some
yeah,
weird reason,
yeah. So I'm sorry for that, kind of frustration. That's the thing about it's free. It's a free program, but it has its hiccups. But yeah, they just wanted you to put just the value that will go in that A spot and just the value that goes in that B spot. So you have the B right for number 2,
okay.
and then A is just positive 1. So if you fix that, I believe you should get your credit for it. And then the others I just took off, because some of those I took off because I just didn't want to give you guys too much homework, because I think some
Okay.
of the it repeats a lot. So, um, so I hope that helps answer some of those.
Yeah, works perfect.
Cool. Awesome. Thank you.
You're welcome.
All right. Let me see. Okie doke. So let's keep the party going. All right. Let's go. Number 5. All right. Solve the compound inequality. Give the solution set in both interval notation and graph form. Okay. So this is an OR compound inequality. Basically, we just start by solving each individual inequality. So we'll go with the first one. We would subtract 5 from both sides. So then we have negative 4y. 5 minus 5 is 0. Is less than 17 minus 5 is 12. Then to solve for y, we'll divide both sides by negative 4. Now when you're solving an inequality and you divide by a negative, you have to flip the inequality sign. So it's going to be positive y, because negative 4 divided by negative 4 cancels to 1. But now we flip the less than to greater than. 12 divided by negative 4 is negative 3. Okay. All right, so that's one solution. Let's do the other one. So we would subtract 5 from both sides. So we have negative 4 is greater than or equal to 33 minus 5 is going to give us 28. Divide by negative 4. And again, we are dividing by a negative number, so we must flip that inequality sign. So then we have y is less than or equal to 28 divided by negative 4, which is negative 7. So now let's graph it, because that's half of our answer needs to be in graph form. So, oh geez, sorry about that. Why did it do that? Okay, so let's plot negative 3 and negative 7. So keep in mind, these are negative values. So negative 7 would be on the left, and then negative 3 would be on the right. Okay, so let's look at y is greater than negative 3. So here's negative 3. The values greater than negative 3 would be on the right. And then it is not equal to, so we're going to use parentheses at negative 3. So now let's look at the next one. Y is less than or equal to negative 7. So here's negative 7. The values less than negative 7 are to the left. And then it's less than or equal to, so we're going to use a bracket at negative 7. So that's the graph form for the solution set. Let's talk about the interval notation. So always think left to right. So starting from the left, we are starting at negative infinity. And it's going all the way to negative 7 with a bracket. That's the first interval. Then we have a gap, then we have another interval. So we're going to say the union, so in conjunction with parentheses negative 3, comma, all the way to positive infinity, parentheses. Now, since it is an OR compound inequality, that means that we want to take all possible solutions. So basically either or, the union of both solutions. They don't have to overlap. So does not have to overlap. Okay? So this is your solution here in interval notation. If this said and, then this solution would actually be no solution, because and inequalities means it must satisfy both this and that. So it would have to, wherever they overlap would only be the solution. But since it's or, we just take all the solutions and put them together as possible solutions. So this is your answer in graph form here, and this is the answer in interval notation down here. All right. Okay, let's keep going. Number 6, simplify the complex fraction. Okay, it's a lot of ways to solve this, but I think the most direct way is to multiply everything by the least common multiple of the entire complex fraction. So look at all of your denominators. We have x, 4, and an 8. So the least common multiple between x, 4, and 8, we think about the numbers 4 and 8. So 8 would be the least common multiple between the number 4 and 8. It's the smallest number that 4 and 8 can be divided evenly into. But we also have to include x as part of our factors. So the least common multiple would be 8x. So let's multiply the entire thing, top and bottom, by 8x. So let's see, we have 8x times 4 plus 8x times 2 over x divided by 8x times x over 4 plus 8x times 1 over 8. Okay. So now we've got 8x times 4, it's going to be 32x, plus 8x times 2 over x, the x's cancel out, and then 8 times 2 is just 16, divided by 8x times x, well 8 divided by 4 reduces to 2 over 1, so then at the bottom, we're going to just have 2, and then x times x is x squared, plus 8x times 1 over 8. The 8's will cancel, and we're left with 1 times x, which is just x. So now let's factor the top and bottom and see if we can continue to cancel anything out. So let's see. So we have a common factor of 16 at the top. So if we factor out 16, we'll have 2x plus 1 remaining. Because if we were to multiply, 16 times 2x is 32x. And then 16 times 1 is 16. Then over, we have a common factor of x. So if we factor that out, we'll be left with 2x plus 1. And so now we check to see if we have common factors on the top and bottom that'll cancel out. And we do. 2x plus 1 over 2x plus 1 cancels out to 1. So all we have remaining is 16 over x. That's your final answer. So you want the least common multiple of the entire complex fraction, multiply everything by that, and then you will drastically simplify it and then look for common factors to cancel out. Okay, let's keep going. Number 7, word problem, yay! Solve the application of systems of linear equations. So Daniel and Rosa are ticket sellers at their class play. Daniel is handling student tickets that sell for $2 each, and Rosa is selling adult tickets for $6.50 each. If their total income for 22 tickets was $102.50, how many did Daniel sell? So Daniel sold student tickets and Rosa sold adult tickets. So let's say that D for Daniel equals student and R is adult. So I'm going to use D and R for my variables. So the number of student tickets plus the number of adult tickets totaled up to 22 tickets. So I can say D plus R equals 22. So this equation represents like the number of tickets sold. Now we want to have an equation to represent the price. So the total price, or the total amount that was in money that was sold, would be, for every ticket Daniel sold, it cost $2. So 2 times every ticket that Daniel sold plus $6.50 times every ticket that Rosa sold equaled a total of 102.50. So this is I'll put the income. So now we have a system of equations here, and then we're going to solve it. So I'm going to use substitution to solve this. So I'm going to take the first equation, because it's a lot simpler, and set it equal to D and solve for D. So D would equal 22 minus R. So I'm going to take 22 minus R and plug it in for D into the other equation. So 2 times 22 minus R plus 650 R equals 102.50. So if we distribute the 2 times 22 is 44. 2 times negative R is negative 2R. I'm going to bring down everything else. I'm going to combine like terms. So negative 2 plus 650 is going to give me positive 450, or 4.5 R, equals 102.50. I'm going to subtract 44 from both sides. So I'm going to have 4.5 R equals 102.50 minus 44 is 58.5. And then divide both sides by 4.5. Then R equals 13. So now let's revisit what it is that we are trying to solve. Okay, so we're trying to answer how many did Daniel sell. So Daniel, we said, represented D. We have R. So let's plug in what we have for R to solve for D. So D equals 22 minus R. Well, R is 13. So D equals 22 minus 13, which we know is 9. So D equals 9. So Daniel sold 9 tickets. If you had solved for R first, plug that in and solve for D the first time, then you would have gotten the 9 earlier. But it doesn't matter, which one you solved for first, because you would eventually be able to get the value that you need to answer the question. So the answer is 9 tickets. All right. Okay, let's keep going. Question 8. AquaWorks is training new employees to assemble hot water heaters. The number of hot water heaters H that a trainee can assemble per 8-hour shift is given by H equals 3.1 times the square root of 0.7T plus 4. where T is the number of days of training the trainee has received. How many training days are required before a trainee can assemble H heaters? So H is the number of heaters, T is the number of days. We are asking for how many days, so we are solving for T. So that means we need to have a value for H. So H is the number of heaters. So our H is going to be 8 because the question is how many days is required to assemble 8 heaters. So we're going to plug in 8 in for H. So then we have 8 equals 3.1 times the square root of 0.7t plus 4. So to start solving for t, we want to start to undo what is around t. So we're going to start by dividing both sides by that 3.1. So 8 divided by 3.1, which you should be using a calculator, not your phone, because you cannot use a phone on the final, is 2.580645. I'm just going to not round too much. Is equal to the square root of 0.7t plus 4. Now we're going to get rid of that square root by squaring both sides. So if we square that value, you end up with about 6.6597 equals 0.7t plus 4. Then we're going to subtract 4. So then we have 2.6597 equals 0.7t. And then finally, to solve for t, we're going to divide by 0.7. So then we have 3.7996 is equal to t. It says round to the nearest day. That's the nearest whole number. So we're going to round this number. We look at the number to the right. It's a 7. Since that is more than 5, we're going to round this up to about 4 days. So t equals about 4 days. Approximately 4 days. So you'll have a problem where it gives you a radical equation. You solve for a particular variable and you have to plug in the other variable that's given to you. Okay. All right, question 9. Use the quadratic formula to solve the equation. So let's remember standard form for a quadratic is ax squared plus bx plus c. That's standard form. And so the quadratic equation is x equals negative b plus or minus the square root b squared minus 4ac, all divided by 2a. Yes, you need to memorize that. And yes, there are tons of videos on YouTube of all kind of ways to remember that. There's like songs and chants and all kind of fun stuff. Okay, so let's identify A, B, and C. The first thing you want to make sure is that your equation is set equal to 0 and in standard form, which this is. So in this case, A equals 5, B equals 3, and C equals 6. So we're going to plug in these values into the quadratic formula. So we have x equals negative b, which is 3, plus or minus the square root of b squared minus 4 times a, which is 5, times c, which is 6, all divided by 2 times a, which is 5. Just be very careful when you're plugging in these values into the quadratic formula. So now we're going to clean this up a bit. Negative 3 plus or minus the square root of 3 squared is 9. Negative 4 times 5 times 6 is negative 120. All divided by 2 times 5, which is 10. Okay? So now 9 minus 120 is negative 111. So we have negative 3 plus or minus the square root of negative 111 over 10. Now, we have a negative number under the square root. Let's fix that by pulling it out of the square root, which is going to make it become an imaginary number. Oh, that's not what I want to do. Okay. All right, again, we have a negative under the square root. We want to get rid of that, make it an imaginary number. So by pulling it out of the square root, that's going to become I, and then we have the square root of 111 over 10. And so now that is our final answer. And then you can split it up if you want and say that x equals negative 3 plus I square root of 111 over 10. And then negative 3 minus I square root of 111 over 10. And so that would be your final answer. Okay. Number 10, solve the linear application. The cost of having a car towed is given by the linear function c of x equals 2x plus 55, where c of x is in dollars and x is the number of miles the car is towed. Find the cost, so the cost is c, of having a car towed 15 miles. The 15 miles is your x. So that means you're going to find c of x, which in this case x is 15. So that means you'll plug in 15 everywhere you see x. So that's 2 times x, which in this case is 15, plus 55. 2 times 15 is 30, plus 55 is 85. So the answer here is $85. Okay. All right. Number 11, solve the system of linear equations using the substitution method. So this is good because we already have one equation set equal to a variable. So we're going to take, so it's saying x equals 46 minus 5y. So that means that 46 minus 5y equals x. So in the other equation, wherever I see x, I'm going to substitute 46 minus 5y. That's going to end up being negative 2 times 46 minus 5y plus 4y equals 20. So we plugged in 46 minus 5y and for x in the other equation. So now we're going to distribute. Negative 2 times 46 is negative 92. Negative 2 times negative 5y is positive 10y. Bring down the plus 4y equals 20. Combine like terms. 10y plus 4y is 14y. Bring down everything else. We're solving for y, so we're going to add 92 to both sides to start to get y by itself. So 20 plus 92 is 112. And then we're going to divide both sides by 14. So y equals 112 divided by 14, which is 8. That is half of the solution. Our solution is a point. It's an ordered pair. So we need to get x. So we already have an equation that's set equal to x. X equals 46 minus 5y. And look at that. We have the value for y. So we're going to plug in that number in for y. So we have x equals 46 minus 5 times 8. And so 5 times 8 is 40. And then 46 minus 40 is 6. So your solution is the point 6, 8. Because remember, ordered pairs are in the form x, y. So your solution, where these two lines intersect, would be 6, 8. Okay, let's look at the next one. Question 12, find the domain of the rational function. So for this rational function, we have a denominator. And remember, we never want, why do I keep doing that? Okay, sorry about that. We never want a zero under the denominator, because a number divided by 0 is undefined. And so we have an x here in the denominator. So we want to make sure we exclude any times that x could be a number that would make the bottom equal 0. So why don't we set the bottom equal to 0, figure out when this could happen, and exclude that from our domain. So if we start to solve for x, we set 7x minus 56 equal to 0 to figure out what x value would make the bottom equal 0. And so then to divide by 7 on both sides, we have x equals 8. So what this means is if we were to plug in 8 in for x, we would end up with some number divided by 0. That's bad. That's undefined. So we want to exclude the number 8 from our possible solutions in the domain. So let me graph what that looks like. So if I want to graph the domain is all of our possible x values. So what we're saying here is that x can be any number in the number system, any number at all, except for 8. We don't want to include 8. No, 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 no. So yes, 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 yes. Nope. Yes, 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 yes. Okay? That's the domain on a number line. Let's write that as an interval. So if we always think left to right, we have two intervals. We have this one, and then we have this one. So always thinking left to right, we're going to start at negative infinity with the parentheses, and it goes all the way to 8, but we do not include 8, so we're going to use a parentheses. We're going to skip over 8, so we're going to use parentheses, and then go on to infinity. So this is the domain in interval notation. And like I said, I find it a lot easier to graph what it is you're trying to express in interval notation, because it almost like literally matches what the graph looks like. All right? Okay. Alrighty. Or if you want to write it in set builder notation, that would simply be the domain is all values for x such that x is a real number and x cannot equal 8. Because if x were 8, we would get 0 in the bottom, and that's a no-no. Okay, question 13. Solve the system of linear equations using the elimination method. So for here, we want to get rid of a variable by adding up equations and canceling a variable out. So we want to create opposites. So right now, we don't have opposites between the x's or the y's. And what I mean by opposites, this is what I mean. Like 6x and negative 6x are opposites because if you add them up, you get 0. Or y and negative y are opposites. Or negative 2s and 2s are opposites. So I want to create opposites in either my x's or my y's. And what variables I use is completely up to me. So it doesn't really matter. I'm going to go with the x's, I guess. So my goal is to create opposites, and for me, in the x terms. Okay, so the easiest way to do that is to multiply the equations by the opposing equation's coefficient. And then depending on what the signs are, you may have to incorporate a sign change. So for example, if I want to eliminate my x terms, because that's my personal goal for this, yours could be the y's. If I look at my x terms, they're both positive. So I'm going to have to multiply one of these by a negative so I can get positive and negative. Okay, so I want to so if I multiply the top equation by 3, I have to multiply the bottom equation by negative 7. If I just multiplied it by 7, then I would get 21 and 21. Those aren't opposites. They're the same. Okay, so let's see what happens. So I end up distributing the 3 with the first equation. So 3 times 7x is 21x. 3 times 6y is 18y. Then 3 times 30 is 90. Now I want to multiply the negative 7 with the second equation. Negative 7 times 3x is negative 21x. Negative 7 times 4y is negative 28y. And then negative 7 times 20 is negative 140. Now I am ready to add the equations, because what's going to happen is that my x terms are now opposites, so when you add opposites, they cancel out. Excuse me. So that was my goal. So now 18 plus negative 28 is negative 10y, and then 90 plus negative 140 is negative 50. And divide by 10, negative 10 to solve for y, so y equals positive 5. That's half of my solution. I need to get the other half the same way I did in the substitution problem by taking 5 equal to y and plug it into one of my equations. So I'm just going to choose the first equation. So the first equation was 7x plus 6y equals 30. And I'm saying that y equals 5. So wherever I see y, I'm going to plug in 5. So 7x plus 6 times 5 equals 30. 7x plus 6 times 5 is 30 equals 30. If I solve for x, I am going to subtract 30 from both sides. 7x equals 0. And then to divide by 7, I have x equals 0. So now I have my solution. My solution is x comma y. So in this case, it would be 0 comma 5. And you can always check your solution by plugging x and y back into each of your equations, and it should get you true statements for both. If it doesn't get you a true statement for both equations, it's not a solution. Okay, let me check for questions. Okay. All right, so let's keep going. Question 14, write the equation of a line in slope-intercept form, whoops, passing through the given pair of points. So you need one of the important things you need to write the equation of a line is the slope. All right, so the slope can be found when you're given 2 points by subtracting the y values from each other divided by subtracting the x values from each other. So it's helpful to some to label your points. So if this is point number 1, this could be x1 and y1. And this is point number 2, that can be x2 and y2. So if you subtract the y's and subtract the x's, that will give you the slope. So the slope of this line would be -6 minus 3 over 8 minus 0. -6 minus 3 is -9. 8 minus 0 is 8. So that's the slope of your line. Now, slope-intercept form is y equals mx plus b. And m is your slope. So this is m. Now we need to start to get the rest of our equation. So there's a handy formula called, or form called point slope form. So this is used to find the equation of a line when you're given the slope and you have a point. Well, we have the slope now and 2 points, so we've got plenty of information. So the form is y minus y1 equals m times x minus x1. So pick a point to use. I'm going to go with the second point. I'm going to use this one because I have a 0, and that may make life a little easier. So that means in x1 and y1, I'm going to plug in the x and y of the point that we are using, and then m is going to be the slope that we found. So y minus y1 is going to be, and then for the sake of this, I'm using what I labeled as x2, y2, but it doesn't matter as long as you're just using a point that's on the line, that's okay. So I'm going to put we're using 0, 3. Okay, so we have y minus 3 equals m, in this case is -9 over 8, times x minus 0. So let's see, if we distribute the -9 over 8, -9 over 8 times x is just -9 over 8x. And then -9 over 8 times 0 is just 0. And we have y minus 3. And we want this to be in slope-intercept form, so we're going to add 3. And then we're going to have y equals -9 over 8x plus 3. And that is in slope-intercept form. Okay. All right. Question 15, rationalize the denominator and simplify. So when you're rationalizing the denominator and you have an expression like this at the bottom, you want to multiply the top and bottom by the conjugate of the denominator. So basically, you're going to, the conjugate of this denominator, you keep the first term the same, and then you just change the sign of the second term. So we're going to multiply the top and bottom by that conjugate. So at the top, if we distribute, we're going to have the square root of 5 times 5 times the square root of 2 plus the square root of 5 times the square root of 5 at the top. At the bottom, we've got 5 root 2 times 5 root 2, outer, plus 5 root 2 times root 5, inner, negative 5 root 2 times root 5, and then last, negative root 5 times root 5. Okay. So just to be clear, this came from the red, and this came from the red. Okay, so now let's clean this up. So what's underneath the square root multiplies together. What's outside of the square root multiplies together. So in this first expression, the 5 is on the outside, and then we have the square root of 5 times 2, which is 10. And then we have the square root of 5 times the square root of 5. That's the square root of 25, which is just 5. So I'm going to just write plus 5 at the top there. Over. Again, what's on the outside is multiplied together. So 5 times 5 is 25. Then what's multiplied on the inside is together. Root 2 times root 2 is root 4. Okay. Here we have plus 5 square root of 10 minus 5 square root of 10, and then minus the square root of 5 times the square root of 5 is the square root of 25, which is 5. Okay, so now the top is still 5 root 10 plus 5. On the bottom, we have like radicals. 5 root 10 minus 5 root 10 cancels to 0. The square root of 4 is just 2. So this is 25 times 2. Excuse me. And then we have minus 5. 5 root 10 plus 5 over 50 minus 5. Okay, so now we have 5 root 10 plus 5 over 45. Now you want to check and see if you have a common factor between all three of these terms. And we only check for we only look in this first one at the 5. Because this is not a 10, that's the square root of 10. So between 5, 5, and 45, they all can be divided by 5. So 5 goes into 10, I'm sorry, 5 goes into 5 one time, 5 goes into 5 one time, and 5 goes into 45 9 times. I need a cough drop. Okay. So what we end up having is 1 times root 10, which is just root 10, plus 1 over 9. And that would be your final answer for this problem. Okay. All right. So all right, let's keep going. Number 16, perform the indicated operation. Write the result in A plus BI form. Okay, so for this one, again, we want to multiply the top and bottom by the conjugate of the denominator. So the conjugate here is going to be 8 minus 2i. So we multiply the top by 8 minus 2i and the bottom by 8 minus 2i. So that's going to give us, I'll just write it all out. Okay, so now let's distribute. 8 times 8 is 64. 8 times negative 2i is negative 16i. 8i times 8 is positive 64i. And 8i times negative 2i is negative 16i squared. Over 8 times 8 is 64. 8 times negative 2i is negative 16i. 8 times 2i is 16i. And 2i times negative 2i is negative 4i squared. Okay, we have I squares. Whenever you see I squared, that equals negative 1. So I like to automatically get rid of those. Okay, so now I have 64. Oops. Okay. All right, 64. Oh my gosh. Okay. Okay, I don't know why that's there. I'm trying to get rid of it. Let me see. All right, 64. Now, negative 16i plus 64i is 48i. And then negative 16 times negative 1 is positive 16. Over 64. Negative 16i plus 16i cancels to 0. Then negative 4 times negative 1 is positive 4. So now 64 plus 16 is 80 plus 48i all over 68. Okay, so let's think of how we can simplify this expression. And probably the best way to think about it is to kind of look at it as two fractions. So we have 80 over 68 plus 48i over 68. So 80 divided by 68 can reduce to 20 over 17. And 48 divided by 68 can reduce to 12 over 17, and that's an I. So that's your final answer. 20 over 17 plus 12i over 17, or you could even say it as 20 plus 12i over 17. But this is multiple choice, so you can choose whichever one they give you. Whoops. Okay. Any questions? Okay. Let's see. All right. 17. Solve the application. Oh, geez. Oh, I think I have a question. Oh, no, I don't have a question. Okay. All right, so let's keep going. Solve the application. A projectile is thrown upward, so its distance h in feet above the ground after t seconds is h equals negative 10t squared plus 320t. What is its maximum height? Okay, so what's happening? You're throwing something upward, and it's going to go like that, right? It goes up, it must come down. What shape is that? That's a parabola, and that is created from a quadratic. Why is my computer freezing? Okay. Now, the maximum height would be here, and that comes from the vertex. All right. Okay. Thought I had questions. All right, so now if we think about it, and so T, this was like on a graph or something, or a coordinate plane. This would be T, and this would be H, the height. So at the vertex, the y coordinate would give you the height, and the x coordinate would give you the time when the height is at its highest point. So if we find the vertex, then the y coordinate is going to be the maximum height. All right. Okay, so let's find the vertex. So the vertex we get by first finding negative b over 2a. That's going to be the x coordinate. So in this case, a is negative 10 and b is 320. So that would be negative 320 over 2 times negative 10. So that's negative 320 over negative 20, which is going to be 16. So 16 is the x coordinate. We need the y coordinate. So we're going to take 16 and plug it into our quadratic. So h equals negative 10 times 16 squared plus 320 times 16. So 16 squared is 256. So negative 10 times 256 plus 320 times 16. Negative 10 times 256 is negative 2,560 plus 320 times 16 is 5,120. So negative 2,560 plus 5,110. Whoa, 5,120 is 2,560. So that would be the maximum height in feet, that's what they're talking about, is 2,560 feet. Okay. I would like to show you how to put in the graphing calculator, but you'd have to give me a sec to set that up. I don't know how much time you guys have. I'm going to be here until I finish. I guess I can see. The two of you, do you guys want me to show you how you could use the graphing calculator to answer a question like this? Yes. Okay, so let me see if I can find. Let me see if I can find the graphing calculator app. You can watch me surf. Let's see. I want to say. I want to look like the TI, so let me try that. Let's see what I can pull off. Let's see all my junk. Let's see. Okay. Hey, technology. Okay, this is awesome. This is great. Okay, so can y'all see that? Awesome. Okay, so if you forgot how to do that math, let's look at how you could use the calculator. So, find the height. So, okay, you could graph this quadratic in the calculator. So y equals is where you'd want to go to graph any function. You need to make sure it's set equal to y. In this case, h equals, that's the same thing as setting it equal to y. So we're going to just use x instead of t. So that would be negative 10 x squared plus 320 x. Now when I press graph, so we don't see it, but that's not because we didn't graph it right. That's because our window is only showing a small portion of the coordinate plane. It's only showing from negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. But if you press zoom and you press zoom out, let's try zoom out and enter. Okay, it's way over there. Let me think, how can I move it to where I want it to be? Okay, let's try zoom fit. Zoom fit, I think, would be what we want. Here we go, zoom fit. So what zoom fit does is that it fits the window to be adjusted so you can see what you need to see based on the graph that you put in the calculator. So this up here, somewhere up here is the vertex. So the calculator can calculate that for you. So see, calculate above trace. So we want this yellow function. So if you press second, that's going to tell it we want that yellow operation. And I want to find the maximum. So if I choose option 4 and press enter, it's now asking me to kind of set a boundary around where the maximum is. So it's just saying put the left boundary. This is to the left of the maximum, so I'm going to just say enter. And I'll just move the cursor over here to the right of the vertex, which is fine right here. So you see how it's kind of setting up little boundary markers. Now it's ready for me to guess, or for it to guess. You say enter, and then, okay, good. I was like, what? Okay, there it is. So you have to know what value you need. So remember I said the x coordinate is your time, and we got 16, so they got 15.999, and then the h is your y. There it is, 2,560. You also could have used this to get the vertex. So that's a shortcut. If you forget how to find the vertex, you could graph the equation, go to second, calculate, and I bet I don't have vertex. Okay, they don't have vertex, but vertex, now if the graph is facing down like this one is, you would want the maximum. That is the vertex. If the graph were facing up, like the U is facing up, you would want the minimum to find the vertex. But this is very helpful to kind of help you find your answer if you end up, you know, forgetting the math. All right? Good. I know I can do that. Okay. So let's keep going. Okay, question 18, factor the polynomial. Okay, so for this, when you're factoring, you always check for a greatest common factor first. In this case, we do not have a common factor to factor out. So then you're going to ask yourself, how many terms do I have? I have 2 terms here. So I either want to check for difference of 2 squares, or sum or difference of 2 cubes. In this case, I have the difference of 2 cubes. I have a cubed minus b cubed going on. So you need to know the factor pattern. So it's a minus b times a squared plus ab plus b squared. So all you have to do is find out what would your a and your b be, plug those values into your pattern, and then you factor the polynomial. So x cubed, that's already set up for us. That's x cubed. Now, 216. What to the 3rd power gives you 216? Well, you can find that out also by using the calculator. So if we press math, it's not letting me use my cursor. Okay. Let me see. I was trying to use this. Let's see. Okay, math. And then we want the 3rd root of 216. And that tells us what to the 3rd power gives us 216. That's 3. Sorry, yeah, 6, sorry. So x to the 3rd, I'm switching back and forth, would be 6 to the 3rd. I'm sorry, 216 is 6 to the 3rd. Sorry about that, guys. I hope you guys are following me. I know I'm all over the place right now. So your a is x and your b is 6. So in your factor pattern, you're going to plug in, wherever you see a, you're going to put x. And then wherever you see b, you're going to plug in 6. I'm trying to use my colors here, thinking that's helpful. So a squared, in this case, that'll be x squared plus a times b plus b squared. So then finally we just have x minus 6 times x squared plus 6x plus 36. And that is your factored form. Okay. All right. Question 19. Sketch the graph of the quadratic function. Give the vertex and axis of symmetry. So, a little kind of shortcut here. You're not going to have to actually graph on the final. It's multiple choice. So, let's practice using the calculator since we've got that option here. Okay. All right, so let's bring it up. Okay, let's put this function in the calculator. So I'm going to go to y equals, I'm going to clear this out, and then I'm going to do parentheses x minus 1, close parentheses, squared minus 1. So notice that I'm going to press graph. It's going to be all weird because remember my window is based on my last equation. So let me go to zoom, and I could either do zoom fit or zoom standard would also get me what I need because this is going to be in the standard window. Okay, so there's my function. That's the sketch of the graph. So you could use that to help you find the graph on the multiple choice questions. Then to get the vertex, so in this case, this would be the minimum. So you can calculate, calculate the minimum. So we want option 3. There's the left boundary. Just cursor over to the right. Here's our right boundary. Press enter to guess. And then now it has given us, I'm not sure why it's having so many decimals, but the minimum, the point is 1, comma, negative 1. That's the same thing as your vertex, okay? Then the axis of symmetry is the same thing as your x coordinate of your vertex. So the vertex here is 1, negative 1. And then this is the same thing as your axis of symmetry. Now, if you also want to find the vertex algebraically, and this is vertex form, f of x equals a times x minus h squared plus k. That's standard vertex form of a quadratic. So the vertex you get from h and k. But notice that the sign changes in h because this is x minus h. So if h is 1, if you were to plug in 1 into your equation, you would get x minus 1. So the way that I always remember this is if I'm given vertex form and I need the vertex, I always think change the h and keep the k. So what that means is change the sign of h. So this is x minus 1. So your x coordinate is positive 1. And then keep the k. So keep the k value the same. K is negative 1. Y coordinate is negative 1. Or you could graph it in the calculator and calculate the minimum or maximum depending on how the graph looks. Okay? All right. Question 20. Multiply or divide, then write the answer in scientific notation. So for this, we're going to start by just dividing 10.64 divided by 4. That equals 2.66. And then now we have 10 to the negative 6 over 10 to the 4th. We're dividing two terms with the same base, so we'll subtract the exponents. That's 10 to the negative 6 minus 4. So that's going to be 2.66 times 10 to the negative 10. And as long as this number is between 1 and 10, then this is good for your final answer. So the final answer is 2.66 times 10 to the negative 10. That was simple. And then make sure you know where we got this from. Okay, let's keep going. Question 21. Divide the polynomials using long division. All right, so we're going to make our big division box. So x squared plus 12x plus 28 is our dividend. And then x plus 7 is our divisor. So we're going to start by taking the leading term in the dividend divided by the leading term in the divisor. So x squared divided by x gives us x, because x times x, so we're going to multiply. X times x gives us x squared. So we should always get the same terms here when we multiply back. X times 7 is 7x. Then now here, we are going to subtract. Oh, I can put this up here. No? Okay. Oh. I am literally learning this as I go. Okay, so subtract x squared minus x squared cancels. 12x minus 7x is 5x. Then bring down the plus 28. Then take the leading term here, 5x divided by x gives us 5. And then you multiply. 5 times x is 5x. 5 times 7 is 30. Just had a mental 35. Just had a mental block. 35. Then we're going to subtract. Why is my tablet freezing? Okay, we're going to subtract. 5x minus 5x cancels out. 28 minus 35 is negative 7. So this is our remainder. So the way we're going to write our answer is the quotient. Okay. Then plus the remainder over the divisor. Another way you could write it, so plus a negative is just minus. That could be just x plus 5 minus 7 over x plus 7. Okay? So that is your answer there. So it's very similar to long division that you did when you were in grade school, but with variables and expressions. Okay. Let's see. 22. Find an equation in slope-intercept form satisfying the specified conditions. So it goes with the point -4, -8, and it's parallel to 7x minus 4y equals -16. So them telling you it's parallel means that you need to find the slope of this given line. And the best way for us to find the slope of this given line is to put it into slope-intercept form. So we're going to change into slope-intercept form, which is y equals mx plus b. So in order to do that, we're going to start by subtracting 7x. So we have -4y equals -7x minus 16. And then divide everything by -4. So then we have y equals +7 over 4x And then negative 16 divided by negative 4 is positive 4. So, of this given line, the slope of this line is 7 over 4. That's your M. Now, the line that we are going to write is parallel to this line. So, parallel lines have equal slopes. So that means that our parallel line is going to also have a slope of 7 over 4. Okay? And then, in order to get the rest of our equation, we're going to use point-slope form using the point that they gave us to get our equation. So let's use negative 4 and negative 8 for x1 and y1. And then we're going to use 7 over 4 for our slope. So we have y minus negative 8 equals 7 over 4 times x minus negative 4. Okay, so 8y minus negative 8 becomes y plus 8 equals, this becomes x plus 4, and then we distribute 7 over 4x plus 7 over 4 times 4. The 4's cancel, and I'm just left with 7. And then we want the answer to be in slope-intercept form, so we're going to subtract 8. So I'm going to have y equals 7 over 4x, and then 7 minus 8 is negative 1. So your final answer in slope-intercept form would be y equals 7 over 4x minus 1. Okay. All right, just 1 second. Okay, so next question. Solve the radical equation. Okay, so for this one, we want to, okay, so for this, we want to start by, we can't isolate the radical because we have two radicals here. So let's put one on one side and one on the other side. So let's subtract this, the square root of 4 minus x, and move it on the right side. So I have the square root of 2x plus 3 equals 4 minus the square root of 4 minus x. So I'm going to start to get rid of the radical by starting with the left. And to get rid of the left radical, I'm going to square it. But if I square one side, I have to square the other side. All right. Now, the left, that just cancels the square root, so I'm going to have just 2x plus 3. But on the right, expanding the right side, be very careful. Don't just square 4 and then square the square root of 4 minus x. This is actually 4 minus the square root of 4 minus x squared is technically 4 minus the square root of 4 minus x times itself. So we're going to have to do some FOILing. Okay? So let's get started. 4 times 4 is 16. 4 times negative root 4 minus x is negative 4 root 4 minus x. 4 times, same thing, will be negative 4 times the square root of 4 minus x. And then the square root of 4 minus x times the square root of 4 minus x is going to end up just giving us positive 4 minus x. Okay. All right. So now this would end up being 16. These are actually like radicals. Negative 4 minus 4, negative 8 square root of 4 minus x. And then we have plus 4 minus x. And then we have like terms here. 16 plus 4 is 20. Minus 8, the square root of 4 minus x. And then we have that minus x. So I'm going to put this here with the equation now, because now I kind of worked it out on the side. Okay, so now let's try to isolate this square root and move everything to the other side. So I'm going to now isolate the right square root. So I'm going to subtract this 20 and add this x. So subtract 20 and add x. So I'm going to end up with 3x. 3 minus 20 is negative 17 equals negative 8 times the square root of 4 minus x. Okie dokie. So now I'm going to divide by negative 8. Okay. So I'm going to have, let me make sure I did something right. Something looks kind of weird to me. Maybe not. 4 times 4 minus x. 16. 4. And then plus 4 minus x. So then 6 plus 4 is 20. Negative 8 minus x. Oh, I think that's right. And then we'll subtract 20. Then add x. Alrighty. Okay, so now I'm going to actually, no, I'm not going to divide by negative 8 because that's going to give me ugly fractions. I am going to, at this point, square both sides to get rid of the radical. Just remember, when you square the right, you have to also square that negative 8. So that's going to be negative 8 squared, and then the square root of 4 minus x squared cancels out. I just have 4 minus x equals 3x minus 17 squared. This is really long. Okay, so now I'm going to have on the right, negative 8 squared is 64 times 4 minus x, 3x minus 17 squared. If I distribute the 64, 64 times 4, let me rewrite the left-hand side, is 256. 64 times negative x is negative 64x. Okay, this is a very long problem. Okay, so now we're going to have to expand the left-hand side. So that's 3x minus 17 times 3x minus 17 equals 256 minus 64x. If I FOIL the left side, I have 9x squared, 17 times 3, minus 51x, minus 51x, 17 times 7, plus 289 equals 256 minus 64x. Okay, so negative 51 minus 51, that's going to give us negative 102x plus 289. Now I am going to set this equal to 0, so I'm going to move 256 and add 64x. So then I got a question. I know. I know, this is a little crazy too. This is long. This is a long one. I don't think you'll have one this long. I think the numbers aren't quite as nice as I would like for it to be for a final exam, but we're gonna plug on through. Let's see, but I'm with you. I'm with you. 9x squared, negative 102 plus 64 is negative 38x. Then 289 minus 256 is positive 33 equals 0. And then this particular problem, we would need to 38 divided by 3. Of course, there's no GCF. Okay. We would need to use the quadratic formula. I hope I didn't skip something here. I don't think I did. Okay. Let's use the quadratic formula. I'm a little afraid that there's a typo somewhere, but I'm going to just keep going. Okay, so we're going to use the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. A is 9, b is negative 38, and c is 33. Okay, negative times negative 38 plus or minus the square root of, this can't be, negative 38 squared minus 4 times 9 times 33 divided by 2 times 9. Okie dokie. Positive 38 plus or minus 38 squared is 1,444. 4 times 9 times 33 is going to give us negative 1,188, all divided by 18. 1,444 minus 1,188. Wow. 38 plus or minus the square root of 256. So this was factorable. Okay. All right, divided by 18. I have run out of paper. Okay, so square root of 256 is 16. So 38 plus or minus 16 over 18. This means this was factorable. Alrighty then. Okay, so 38 plus 16 is 54 over 18. And then 38 minus 16 is 22 over 18. 54 divided by 18 equals 3. 22 divided by 18 is going to give you a fraction, which is 11 over 9. Okay, so those are your solutions. There's got to be must have done it I had to done the long way. Let's see. Yeah, I don't even have anything inspiring to say about this. But that is the answer because I can see it on the computer. Um, I mean, yeah, I really wish there was a simpler way, and I'm betting there is. Because I'm telling you, I'm working these kind of fresh off the dome with you guys. And I'm trying to see if I can figure out where I could have, okay, where I possibly could have made this shorter. Maybe from the beginning. I bet from the beginning, maybe. Let me try something. This is kind of bothering me. Let me see here. Let me enter a page. Wait. Okay, let me try something here. Don't let me get you dizzy. I know I'm kind of freehanding this, but I'm worried that I did a long version. I don't want. Oh, that's my son's school. Okay. I don't want to confuse, oh, I know I probably confused you, but I wanted to see if there was a shorter way to do this. Okay. All right, let me try something else. I don't know if this works, so this is me being vulnerable in front of my students, so don't judge me. We all go through it. I'm going to try to square both sides here. But if I do that, I need to write this twice. Four squared is just 16. So let me see what happens. If I FOIL, I bet this is what I should have done first. So, yep, that's probably what I should have done first. Yeah, I'm seeing it now. Okay, when you multiply two expressions, they both have square roots. They have the same thing under the radical. You just get rid of the radical. Like the whole idea is, yeah, I'm kind of embarrassed now because I kind of see how this would have been easier if I had not done it the way I did it. And now my tablet's frozen. I'll wait till it comes back to life. Okay. So you know how if you, like the square root of x times the square root of x is the square root of x squared, which is just x. Or like, hold on 1 second. Oh geez, stop it. Oh my gosh, what is this? Okay. Or like if you have the square root of 3 times the square root of 3, that's the square root of 9, which is what? 3. So if you look at this here, the square root of 2x plus 3 times the square root of 2x plus 3 is going to give you just 2x plus 3. Then the square root of 2x plus 3 times the square root of 4 minus x ends up being Okay. Big square root of 2x plus 3 times 4 minus x. Okay. Then plus big square root of, yeah, same thing, 2x plus 3 times 4 minus x. Then the square root of 4 minus x times the square root of 4 minus x is just 4 minus x equals 16. Okay, yeah, this is looking better. So now I've got like terms. I have 2x minus x, which is x. 3 plus 4 is 7. And then these are the same things added together. So that's just plus 2 of all of that. Equals 16. So now, yeah, this is looking better. Okay, so now I'm going to isolate this square root. So let me subtract x and subtract 7 from both sides. So I have 2 times the square root of, and I could go ahead and FOIL this, but I'm just not yet, but I have to anyway, equals, okay, negative x, and then 16 minus 7 is 9. Then I'm going to divide by 2. Yeah, I could divide by 2 now or later. I'm going to do it later. I'm not going to divide by 2. I'm going to square now to get rid of the square root. So that's going to be 2 squared is 4. The square root of this expression squared cancels the square root. And I just have 2x plus 3 times 4 minus x equals, and then here I'm going to have to expand this. This isn't really shorter, but probably spent a good 20 minutes on this problem, but I just wanted to see if there was a more direct way. Okay, but I have gotten rid of my radicals earlier, so that is good. So now I just have a lot of multiplication. So that's 8x plus 12 times 4 minus x. And I'm going to do lots of foiling. So that'll be 32x minus 8x squared plus 48 minus 12x equals positive x squared minus 9x plus 81. Okay, and then I'm going to move everything to one side of the equal sign and set it equal to 0. This should be negative, I think. Yeah. Before I do that, let me combine like terms. 32 minus 12 is 20x minus 8x squared plus 48 x squared minus 18x plus 81. Move everything to one side. Minus x squared plus 18x minus 81. equals 0. I'm going to put this in correct order. So negative 9x squared plus 38x. Yep, that's where we started. Minus 33. Yep, that's what we had. And then we still ran out of room. Then we're going to factor out a negative. So then we'll have negative times 9x squared minus 38x plus 33. And use the quadratic formula, or if you can figure out how to factor it, but that's pretty difficult to factor because if you do AC method, you get 9 times 33. But yeah, so we did it right the first time. It's just this is it's a hefty problem. It is a pretty hefty problem. So feel free to look at that video later to kind of try to follow what I did. But there is a problem like this in the textbook. The thing with this problem is that the numbers were large, so it really made our work to become a lot. But okay, I think I spent enough time with that problem. But continue to do the review so you can see lots of versions of it, but they should not all be that extensive. Okay, this is a little lighter on the brain. So we've got find the compound inequality. It's an and problem. So let's solve them individually. So I'm going to start by subtracting 6. So 5x is less than negative 20. Divide by 5. X is less than negative 4. Okay, that's one part of our solution. Then for the next one, I'm going to add 4. So I have negative 7x is greater than negative 25 plus 4. So that's going to be negative 7x is greater than negative 21. Divide by negative 7. Here I am dividing by a negative, so I need to flip my inequality. So x is less than positive 3. This is an and inequality. So let's look at what that means in terms of solving it. Okay, so let's graph what we have. So we have negative 4 and 3. So for this one, x is less than negative 4. So less than negative 4 would be to the left. And then we are not including negative 4, so we're going to use a parentheses. For x is less than 3, it's all of our values less than 3 will be to the left. And we are not including 3, so we're going to use parentheses. And inequality means that we need to only include where the two solutions overlap. Okay, so we only want this part here. That's the only place where they overlap. So we're going to write our solution in interval notation only using the purple region. So we're starting at negative infinity and we're going all the way to negative 4 with the parentheses, but that's it. We do not include this region in the red because that is not also a part of the other half of the solution. My tablet's freezing. It's getting tired too. We're almost done, guys. You're doing great. Come on. Okay, do not include. So this is your solution. Negative infinity to negative 4, both with parentheses. And let me make sure that is how they want the answer inputted. They actually want an interval notation. No, sorry, set builder notation, which would be just, okay, so if we want to write it in set notation, all values for x, such that we only want the values in the purple. So what we have in the purple is just x is less than -4. That's it. Okay? Not, the 3 is not a part of our solution because it's an and inequality. So it's not overlapping with the other one. Okay, 25. Subtract the rational expressions. Simplify your answer in lowest terms. So in order to subtract, we need to get common denominators. And to figure out what factors we have, let's factor everywhere possible. So in the bottom here of the first rational expression, we can factor this. It's going to be x plus 5 times x minus 5. That's difference of 2 squares minus x over x minus 5. So for your least common denominator, we need for all factors to be accounted for. So we definitely need to have an x minus 5 in the least common denominator, but we also need to have an x plus 5. So we're going to multiply, if we multiply this expression by x plus 5 on the top and bottom, then we will have common denominators. So then the denominator would be just x plus 5 times x minus 5. And the top will be 7x minus x times x plus 5. All right. So now that's 7x minus x squared minus 5x over x plus 5 times x minus 5. Let's write the top in correct order. Negative x squared plus 2x. Oh, goodness. Okay, so we have, let's try this again. So negative x squared, and then 7x minus 5x is 2x divided by x plus 5, x minus 5. And then let's see, if we factor out anything at the top, that actually won't help us simplify or cancel out anything with the bottom. So we can actually stop right there. So if we wanted to, we could write the bottom as x squared minus 25, or we can just leave it right here. So this will be your final answer there. Okay, 26. A ball is thrown upward with an initial velocity of 21 meters per second from a cliff that is 70 meters high. The height of the ball is given by the quadratic equation h equals negative 4.9 t squared plus 21t plus 70, where h is in meters and t is the time in seconds since the ball is thrown. Find the time it takes the ball to hit the ground. Round your answer to the nearest tenth of a second. So find the time it takes the ball to hit the ground. So when the ball hits the ground, its height, we consider that to be 0 meters. Okay? So basically we're going to say h equals 0 and solve the quadratic. And since it is in, there's decimals in here, we're going to definitely use the quadratic formula. So, again, that's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's label our a, which is negative 4.9, b is 21, and c is 70. So we're going to plug in those values. So we have negative 21 plus or minus the square root of 21 squared minus 4 times negative 4.9 times 70, all divided by 2 times negative 4.9. Okay, so we have negative 21 plus or minus 21 squared is 441. Negative 4 times negative 4.9 times 70 is positive 1,372. All divided by 2 times negative 4.9 is negative 9.8. 441 plus 1,372 is going to equal 1,813 divided by negative 9.8. So we've got two solutions here. Negative 21 plus the square root of 1,813, all divided by negative 9.8. Then negative 21 minus the square root of 1,813 divided by negative 9.8. Okie doke. So you can put that in the calculator with kind of ease. I would put it in the calculator. And let me show you what I would do. Hold on one sec. Yeah, okay. So here's what I would do. Let me switch it over. Okay. So this is what, to make this process a little simpler for you. So you can put the numerator in the calculator. So negative 21 plus the square root of 1,813 equals, that's the numerator. Then if you immediately press divided by negative 9.8, that gives you one solution. Then if you do the second one, negative 21 minus the square root of 1,813, enter, that's the numerator, divided by negative 9.8, that's the second solution. Now, we are talking about a real situation in terms of time. So you don't have negative time. So we're going to not use the negative solution. We want the positive solution. So it says to round to the nearest tenth of a second. So 6.487, we will round that to 6.5. So it'll be 6.5 seconds for number 26. All right. Okay. Okie dokie. So solve the equation by factoring. Okay, so here I look at the leading coefficient. It is a 1, so I'm going to go ahead and set it up with x and x. It's all positive signs, so it's going to be positive signs in my factors. Now I need two numbers that multiply to give me 32 and add together to give me 12. And that's going to be 8 and 4. 8 times 4 is 32. 8 plus 4 is 12. And once I factor, I just set the factors equal to 0 and solve them individually. So x equals -8 and x equals -4. That wasn't so bad. Okay. All right, and then we have number 28. Use the rules of exponents to simplify the expression. Write your answer with positive exponents. So we're going to just distribute this y to the 1/3. And yes, you have fractions, but yes, you have a calculator. So I will make sure and show you if you struggle with multiplying, adding, or subtracting fractions, your calculator will help you. So let's distribute here. So y to the 1/3 times y to the 4/9 minus y to the 1/3 times 5y to the 2/9. Okay, so here we're multiplying, so we add the exponent. So that is basically y to the 1/3 plus 4/9 minus 5y to the 1/3 plus 2/9. Now we can definitely do it by hand. We want to have common denominators. A common denominator between 3 and 9 could be 9. So to get 9 in the first fraction here, I'm going to multiply it by 3. So that would end up being y to the 3/9 plus 4/9 minus 5 times y to the same thing, 3/9 plus 2/9. So that would end up being y to the 7/9 minus 5y to the 5/9. And then we can't combine these two terms because they do both have y's, but they don't have the same exponent. This would be your final answer. Now, just to show you, you can double check your math in your calculator. Let me get my calculator here. So if I want to do 1/3 plus 4/9, you can do that by using the divisions button. I like to put my fractions in parentheses. So 1 divided by 3 is 1/3 plus 4 divided by 9. That's 1/3 plus 4/9 equals, now that's a decimal. I don't want that. I want the fraction. If you press math, it's going to change your decimal to a fraction. If you select that first option, number 1, then you press enter and it will give you the fraction. So please feel free to use this if you need to when you work through these problems. Okay? All right. I think we're almost done. Okay, question 29. Solve the rational equation. A contractor finds that it takes Sam Tockett 10 hours to construct a wall of a certain size. It takes Jim 8 hours to construct the same wall. How long would it take if they worked together? So we're going to solve this like this. It takes Sam 10 hours to construct the wall. So he could get the 1/10 of the wall done in 1 hour. Jim can construct the wall in 8 hours. So it would take him, he could get 1/8 of the wall done in 1 hour. So if we set that equal to 1/t, how much could they get done together? Excuse me. We would set up the equation like that. So to solve this, we're going to multiply by the least common denominator between 10, 8, and t. And that is going to be 40t. 40t. Because 10 can divide into 40 evenly, 8 can divide into 40 evenly, and t can divide into t evenly. So we're going to multiply everything by 40t. So 40t times 1 over 10 plus 40t times 1 over 8 equals 40t times 1 over t. So 40 divided by 10 is 4. So we have 4t. 40 divided by 8 is 5. So we have 5t equals, t divided by t cancels. We just have 40. So 4t plus 5t is 9t equals 40. Divide by 9. So t equals 40 divided by 9. And then if we want to write that as a mixed number, 40 divided by 9 is 4. 4 times 9 is 36, so we have a remainder of 4 over 9. So 4 and 4/9 hours it would take them to do the wall together, construct it together. And then last but certainly not least, number 30, solve the absolute value equation. So to solve the absolute value equation, we're going to first just drop the absolute value signs and write the equation. And then for the second one, we're going to write the first expression exactly the same and then negate the second. So distribute a negative with the second. So we're going to just solve our equation. I'm going to move the x values to the left. So I have x minus 3 equals 7. Add 3 to both sides. X equals 10. Then here, let me distribute my negative first. So that's negative x minus 7 on the right. So it's 2x minus 3 equals negative x minus 7. And I'm going to start to solve this equation. 3x minus 3 equals negative 7. Add 3. So 3x equals negative 7 plus 3 is negative 4. Divide by 3. So x equals negative 4 over 3. So your solutions are going to be x equals 10 and x equals negative 4 over 3. All right. And I believe we have reached the end. So that was fun. Okay, so remember, your final exam is due on, let me do big, not trying to be obnoxious, but I need y'all to know. Thursday, 4/27 in Valencia Testing Center. I want to have grades done on Friday. I'm just going to tell you, I'm going out of town this weekend, out the country. Good stuff. Email me next week. I'll send you pictures. But I need to have these done before I leave. So your final exam is due Thursday by the 27th. No excuses, all right? If you don't take the final exam, I don't hear from you or anything, you will get a 0 on the final exam, and wherever that brings your grade, that will be your grade, okay? The depot is open if you're at Osceola campus. The depot is open all week next week, regular hours, so please feel free to come in. You know, we have dojos also in addition to the computers in the back. The tutors in the front also tutor intermediate algebra, so you have lots of help if you need it. And then the other campuses have their math tutoring centers as well. and they're running on the same, their own operating hours. So get all the help you need. Don't wait to the last minute. Take that final exam review as many times as your brain allows you to, because it is very, very much like the final exam. Okay? Let me see here. So I see your question. We're going to talk to you individually. So with that, if there's no questions, and I see the one question, I'm going to answer that one. Feel free to email me, give me a call. If you call me, leave a message on the voicemail so I can give you a call back from out of the office. But I'm here for you. You're almost done. Just finish strong. And thanks, guys, for hanging with me this afternoon. Okay, thanks.